This section discusses the solubility of solutes in solvents. So the solubility of a solute in a solution is defined as the amount of solute that can dissolve in a certain quantity of solvent. The solubility of a solute depends on the temperature of the solution, the state of the solute, and its affinity for the solute. We often see solubilities expressed in grams of solute per 100 grams of solvent. So let's look at some examples here. I have CH3OH, CH3Cl, and CCl4. And as I go down, the polarity of the solute is decreasing. So CH3OH here, I have hydrogen bonding here, that's very polar. And CCl4 is nonpolar. And look what happens to the solubility in water. This is at 23 degrees Celsius, which is approximately room temp. Okay, so CH3OH has infinite solubility in water because, again, water is a very polar solvent, and I have a very polar solute in the CH3OH. And then down here with the CCl4, look at how small the solubility is. 0.081 grams of CCl4 will dissolve in 100 grams of water. And again, that's because CCl4 is nonpolar, while water is a very polar solvent. And so we have an extremely poor solubility in water. The phrase like dissolves like is what we're dealing with here. So like solutes dissolve in like solvents. Okay, so polar solutes dissolve in polar solvents like water. A nonpolar solute like CCl4 needs a different solvent that is nonpolar. The solubility of a solute in a solvent is highly temperature dependent. Okay, in general, solids and liquids dissolve better at higher temperatures. So solids and liquids dissolve better at higher temperatures, whereas gases are more soluble at lower temperatures. So let's look at this. We have sodium chloride, okay? The solubility of sodium chloride, which is a solid, right? And as the temperature increases from 0 degrees to 100 degrees Celsius, so does the solubility. So from 35.65 grams per 100 grams of water up to 38.99 grams per 100 grams of water. Whereas, let's look at this gas, NH3 gas, and I've switched here to milliliters of gas per milliliters of water. Obviously easier to measure the volume of a gas than it is to measure the mass in grams. So again, as I increase my temperature from 0 to 100 degrees C, look how much the solubility decreases from 11.7 milliliters per 100 mils of water all the way down to 0.88 milliliters per 100 mils of water. Why is that? Why does the solubility of a gas decrease with temperature increase? It's because remember that if the gas molecules have high kinetic energy, or in other words, high temperature, they're likely to weaken any solute-solvent attraction, and then they just escape the solution entirely. So we have really low solubility here because the gas is going to just want to leave the solution the more kinetic energy it has. This is why you want to keep soft drinks and carbonated beverages in the fridge cold before you drink them, because the CO2 gas is more soluble at lower temperature than it is at higher temperature.